Hello everybody. It is time for us to start looking at some similarity transformations. So that means that we are going to talk about how our dilations relate to the other transformations that we learned in chapter 3 last trimester. So starting with number 9, is it possible to use only translations and dilations to map one circle onto another and explain? And yes, that is super easy actually. So we can say yes, because all we need to do is translate them so the centers align. So translate so the centers align. And then we're going to dilate them. And we're going to take the radius of the big circle divided by the radius of the small circle and use it as a scale factor. So, and dilate using the ratio of the radiuses, the ratio of the radii. The ratio of the radii. Not rated. Nope. Radii. All right. Number 2, Keegan was asked to graph a rotation of 90 degrees composed with a dilation of 2 of triangle ABC. So if we took triangle ABC and we dilated it with a scale factor of 2, it doesn't say what's our center of dilation, which means the origin is our center of dilation. If our origin is the center of dilation, then our shape is going to get further away from the origin. Instead of being up 1 over 1 from the origin, it's now going to be up 2 over 2 from the origin, and then twice as big. So then we have a side with a length of 4 instead of 2, and a side with a length of 6 instead of 3. And that's going to be our new shape. So we can say no. Well, we can't say no. We already know Keegan made an error. To explain what he did, we can say the shape should move further from the origin after the dilation. The shape should move further from the origin after dilation. There we go. Number 11, in this diagram, ABCD is similar to A prime, B prime, C prime, D prime. What are the angle measures of A prime, B prime, C prime, D prime? So, let's see. What we can say is we can figure out what some of these are. We know the angle measures of a dilation will be the same as the angle measures of the original figure. So all we need to do is figure out the angle measures of the original figure. So let's see what we can do here. I know that if this is a 125-degree angle, then we have a supplement here that's 55. And I know that if a triangle has 180 degrees in it, and this is 48 and this one's 55, we can do 180 minus 48 minus 55, and that will give us 77 degrees for D. I see some vertical angles, so I know the other side of D is also 77 degrees. I can see that this is an 80-degree angle, and I have parallel lines. So this angle up here is an alternate interior angle with 80, so that means it's also 80 degrees. Not 88, but 80. Then I can also tell that this 80 is a linear pair with this angle right here, which means it's 100, since 100 plus 80 is 180. And then since I know that all of the measures of my quadrilateral add to 360, then I can just do 360 minus 77 minus 80 minus 100 and find that A is 103 degrees. So I'll copy them down here. A prime will be the same. It'll be 103. B prime will be the same as B. That will be 100. C prime will be the same as C, which is 80. And D prime will be the same as D, which is 77. All right. Number 14. This one's a little bit tricky to think about. Given isosceles triangle ABC, with AB is congruent to BC. Let's do that. Here's a triangle. We'll make it isosceles. And we can say A, B, C. That way AB and BC are the same length. Point D is the midpoint of AB. Point E is the midpoint of BC. And F is the midpoint of CA. So this is D, E, and F. Use a similarity transformation and describe the congruence to show that triangle ABC is similar to triangle DEF, which is this triangle right here. So first we need to make ABC smaller. So we can say dilate ABC with scale factor. Well, what scale factor is going to make this side half as long, right? Each of the side lengths is half of the old side length. So we're going to use scale factor 0.5. And center. It doesn't really matter what center we use. Maybe we'll pull the whole thing this way and use the center C. Make it really small. We would end up with this triangle right here. So in center C. After that, we would reflect it over line FC to make triangle DEF. That would be the last thing we need to do. We would shrink it down into this corner. We would reflect it over this line, and we would get triangle DEF. Number 15, we've got this translation of 5, negative 4, composed with a dilation of 1.5 for x, y, and z. Of course, we're going to take all of those coordinates and multiply them by 1.5, and then we are going to then add 5 to the x and subtract 4 from the y. And we should end up with x prime, which is 14, negative 7, y prime, which is 11, negative 2.5, and z prime, which is 2, negative 0.5. Number 16, similar thing. I'm going to dilate with a factor of 0.5 by making every one of these points half as big. And then I'm going to reflect it over the x-axis by making the y-coordinates negative of what they were. So I'm going to end up with L prime at 1, negative 2, M prime at 2, negative 2, N prime at 2, 2, and P prime at 1, 2. All right, number 19, for each black preimage and red image, describe the similarity transformation and write a similarity statement. So let's see, if we take this shape and we move it, we can move it a lot of different places, but maybe I'm going to move it so that the corner of the new shape matches up with the corner of the old shape. So maybe I'll move it right over to here, just like that. So that would be a move, that would be a translation. And it'd be a translation over 4, and it would be a translation down 2, so negative 2. And after that translation, I would combine that with a dilation, and that dilation would make it twice as big. I gotta get the door here real quick. Give me just a moment. 1 second here. Sorry about that. That was student council giving me some candy. Happy with that. It's Halloween today. Let's see. So a translation of 4, negative 2 combined with, and then after we combine, we end up dilating it with a scale factor of 2 but we're using point D as the center of dilation, since we're going from point D and we're growing outward and making those sides double the length that they were. So that would be my similarity transformation that I'm using there. Next, let's see. Down here, for each black pre-image and red image, same thing. We are starting with the pre-image, which is the small one, and the red one is the larger image. Looks like what I could do is I could make point A move on to where point Z is. Could line it up and make it just a little small triangle in here. And I would do that by probably reflecting. So my first move would be a reflection over the line x equals -3. That's my vertical line right here. And after I do that reflection, I'm going to need to grow the shape. So I'm going to combine it with a dilation. And it looks like, let's see what my scale factor would be. This line is up 1/2. Its corresponding line is up 2/1. Its corresponding line is up 4/2. So it's a dilation with a scale factor of 2. And since I will have lined up point A to where point Z is at, that would make it a dilation with a center of Z. So dilation, scale factor of 2, center Z, composed with a reflection over x equals -3. Do the figures appear to be similar in explain? In 22 they do. So yes, and we can tell that because the arcs or angles are the same. You can say same angles and arcs, even though they're different sizes. Number 23, when we look at those angles, we can see that those angles aren't the same, even though the sides are congruent. So we can say, no, those have different angles, which makes them not similar. Different angles. All right, number 24. Can Ahmed use the larger sheets of paper to make paper cutouts similar to his original hummingbird cutout? If not, how can he trim the sheets of paper so that he can use them? Well, if we want to use the larger sheet of paper, we've got to see if the papers are proportional. So we want to see, let's see, if not, how can he trim the sheets of paper so he can use them? Larger sheets. Okay, so we're going to see if a 9/12 page, 9/12, is proportional to a 120/180 page. And we can do this in a couple of different directions. I can say, well, what would be the scale factor between 9 and 120? I can say 120 divided by 9 gives me 13.3. If I do 180 divided by 12, I can put it in my calculator correctly, I get 15. So my scale factors are not the same. Could he use the other paper? Is that one proportional? So I can check and see if a 3/4 sheet of paper will be proportional to a 9/12 sheet of paper. And I can do that by saying, well, 3 times 3 is 9. 4 times 3 is 12. So he can use the 3x4 paper. So he can use the 3x4 paper. But what if he wants to use the other one? If we wanted to use the other one, we would have to say, well, if it is going from 9 to 120, we're trying to cut, let's see, we're trimming the sheets of paper. So we're trying to trim the 120 to 180 sheet of paper. 120 divided by 13.3 is 9. I'll have to do the same transformation from 12 to get to 180, or to get to my new number here. So I'll do 12 times 13.3, and I get 160. And so I can say, and trim the other to 120 by 160, and that will make that paper proportional to the 9x12 inch cutout as well. Number 26, Juanita wants to make a dollhouse following the pattern shown, but with a reduced size so that the floor has an area of 25 inches squared. Make a sketch showing the dimensions of the pieces for the smaller dollhouse. So she wants the floor to have an area of 25 inches squared, which means she will want the floor to have a 5 by 5 reduction. So we just need to figure out, well, what's the scale factor from a 6 to a 5? So I can do 5 divided by 6. That should be a 6. Because that's going to be my new side length divided by my old side length. And that's 5 divided by 6 is 0.83 repeating. So if I multiply all these other pieces, all the other side lengths by 0.83 repeating, I'll get the same scale factor. So the side here, this 6 becomes a 5. Then if I do 9 times 0.83, I get 7.5. If I do 13.5 times 0.83, I get 11.25. For the back, I had a 6, which is now a 5. I have a 13.5, which is now an 11.25. For the roof, I had a 9, which is now 7.5. And a 6, which is now a 5. I can't write and talk today. For the front, I had a 9, which is now a 7.5, and a 6, which is now a 5. And for the side, I had a 6, which is now a 5, a 9, which is now a 7.5, and a 13.5, which is now an 11.25. So those would be the dimensions of the reduced dollhouse. Number 28, what are the coordinates if I take 8, 2 reflected over the x-axis and dilate with a scale factor of 4? So 8, 2 reflected over the x-axis would be 8 comma negative 2. We'd change that y-coordinate. And then if I multiply it by a scale factor of 4, that would be 32. Negative 2 times 4 is negative 8. So that would be choice D. And that's it for 7-2. If you've got any questions whatsoever, of course, make sure to ask me in class, and have a wonderful day.